Okay, we come to this chapter on kinematics. Okay, and how is that related to our integration topic? Okay, it's highly related because the other major application of integration, other than finding the area bounded between two functions and a range, is actually applied in this thing called kinematics. Okay, which is essentially an upper hand for you who are studying physics. Okay, because there are some terminology that you would have come across before in your Sec 3 physics work. Okay, and the very first word that actually come across that is familiar to us is actually this thing called displacement. Okay, and what is displacement? Now, displacement is actually defined as the change in position of the particle with respect to what? With respect to a fixed point. Okay, a fixed point at a particular instant. Now, in mathematics, that fixed point is usually denoted by O. Okay, and for displacement, right, you also know that it has both two things. It has both the magnitude and it has also a direction. Okay, so because of the fact it has direction, it becomes a vector entity. So therefore, it can be positive, it can be 0, and it can be negative. Okay, in calculus, displacement is defined as s equals to a function of t. Okay, we'll see this more in the examples to come. Okay, now we usually denote the following for displacement of a particle from a fixed point O. So like I say, it's actually O. Now number one, if s is greater than 0, that means it's on the positive s-axis. Okay, let me just draw the sketch for you. Okay, so this is, let's say, O. Okay, anything that is over here, s is greater than 0. So it is the positive s axis. Now if s is equals to 0, the particle is actually at the point 0. Am I positive? Maybe right. Let me write it. Okay, nicer. Okay, now s is smaller than 0, that means it's anything, everything from here. Okay, now that only says that, well, it's on the negative s-axis. Okay, so the contrast to displacement, there's another word called distance. Distance and displacement are two different things. In this whole chapter, distance is actually defined as the total length that the particle covered within a given time. So it has only a magnitude. It doesn't have any direction because it's length. And therefore, because it's only magnitude, it actually is always positive. Now a lot of times, and I will show you in the examples, in finding the distance covered by a particle, we usually need to sketch. We usually sketch of the displacement position of a particle. Now the next thing you know or you need to know is what we call velocity. A lot of words, a lot of terminology to know. What is velocity? Velocity is defined as the rate of change of not distance but rate of change of displacement. Speed is defined as the rate of change of distance. But in this case, we most likely 99.9% we are looking at this word called velocity. So it's pegged to displacement, not pegged to distance. Now in calculus, velocity is defined as v, because it's rate of change of displacement, v equals to ds over dt. Where s is the displacement of the particle at time t. So we usually denote the following for velocity of a particle. Let's say your v is greater than 0. Meaning the particle is moving in the direction of the positive s-axis towards the right regardless of position. So it can be on the negative displacement, but it's moving towards the right. Okay, now v equals to 0, that means to say the particle is at, wow, this word very difficult to spell, instantaneous, okay, rest. Okay, there's only two scenarios, okay, and usually, okay, it is not about the particle stops, rather, okay, it's more about the particles turns. Okay, so it turn, it go into a different direction. Okay, like 你回转转回去这样. Okay, so v equals to 0. Now v is smaller than 0, of course it's moving in the negative s direction. That's why I don't need to ask you to fill in that. Okay, so there are situations whereby, okay, I draw this again. Let's say this is s, this is 0. Okay, there will be situation at this is s smaller than 0, the particle is moving at v being positive. Okay, on the other hand, okay, there can be also scenario whereby again s 0, okay, now where here s is greater than 0, okay, the particle is moving at the opposite direction, v is negative. Okay, so don't pack them together, both must be positive, both must be negative. No, look at the scenario, look at the question itself. Okay, now the last thing that you probably need to know is what we call acceleration. Okay, so what is acceleration? It's the rate of change of what? Velocity. Okay, so in calculus, okay, it's defined as a is equals to dv over dt, and since v is ds over dt, a is also d2s over dt square. Okay, so where s and v are respectively the displacement and velocity of the particle at time t. So again, okay, it does have, okay, greater than 0 equals to 0 and smaller than 0. So if let's say a is greater than 0, that means the particle is just speeding up. That's all. Okay, now if it's equals to 0, is it still moving? Yes, but it's moving at constant velocity. Okay, and with smaller than 0, it's actually slowing down already. Then probably you'll come to a stop somewhere. Huh? Okay, now the thing that we do to approach kinematic question is number one, okay, we need to determine its initial direction, okay, of the motion. Okay, the sign of v when t equals to 0. Now the second thing that we really need to do is actually unpack for you, is we need to find the times where v equals to 0. Okay, so to what? To find out when is the particle at rest. Okay, which is likely due to reversing to, okay, its direction. We'll talk more about this when we look at more examples. Okay, you realize that it's guided. Okay, a lot of velocity, time, a lot of kinematic questions, they're all guided. Okay, so let's jump into example 1 right now.